is we are going to look at 2.6, prove statements about segments and angles. You're going to remember from yesterday, you started some proof items. You looked at substitution, addition, subtraction, reflexive. We're going to talk a little bit about that at the end of this video. But first of all, we need to discuss again what a proof looks like. A proof for our purposes will be a double column proof, and it looks like the gray item down below. You're going to have a given statement, which is listed first. It is the hypothesis of the if-then statements. The second part is going to be the prove, and that is the conclusion or the second part of a conditional statement. Now you're going to notice that we have something that creates two columns. The first part is the statements, the second part is the reasons. When you do proofs for this class, you're going to write that out at the top of your two-column proof. Notice that you number the left-hand side and number the right-hand side, and that's really important as you're doing your proofs. Now, just FYI, there are other types of proofs. There's a paragraph proof, a flow proof, but for our class, we will be working on the double column proof, which looks like this. Let's go on and let's do an example of a proof. So you're going to notice that the first statement is the conditional statement. If a triangle is a right triangle, that is the hypothesis. Then the acute angles are complementary. That is the conclusion. Okay, so you're going to notice that what we're trying to do is we're trying to prove the conclusion. You're going to notice in the proof that they gave us, there is a given. Triangle ABC with right angle B. That's given. You're going to notice that 99.9% of the time they start off the proof with the given statement. So you're going to notice number 1 down here in the statement, it says that angle B is a right angle. So we're going to write given, because you're going to notice that it's right up here. B is a right angle. Okay? Now we're going to keep going, and you're going to notice number 2. Number 2 says that the measure of angle B is 90 degrees. You'll notice that that is not in the given statement. But what it does is we're looking at number 1 and we're going to number 2. And what in number 1 tells us that the measure of angle B is 90 degrees? Well, what tells us that it's 90 degrees is the idea that B is a right angle. So for these, what we're going to do is we're going to go definition of, okay? And whenever it's kind of like a duh statement, like, oh my gosh, it's right there, we're going to use definition of, and that'll be one of the reasons that we use. And it's going to be definition of right angle, because the definition of a right angle says it's 90 degrees. Okay, now we're going to take a look at number 3. You're going to notice that number 3 says the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. This is called the triangle sum postulate. We're going to be writing that down as a reason for a proof. So just hang on, that'll be coming up. All that says is that if I take the angles of a triangle, they're going to equal 180 degrees. All right, now we're going to go on to number 4. Number 4 says the measure of angle A plus 90 plus the measure of angle C equals 180 degrees. You're going to notice that that is not in the given. So what I'm going to do is I'm going to take a look at number 3, and I'm going to go, what did I do to number 3 to get number 4? Okay. Well, you can look and notice that right in here, the measure of angle B was taken out and 90 was put in for that. We know that because of number 2, that they are equal to each other. So the reason for this is substitution. I took out something and I put in something that's equal to it. Now we're going to go to number 5. Number 5 says the measure of angle A plus the measure of angle C equals 90 degrees. And so what I did was I'm taking a look at number 4 again. What did I do to 4 to get 5? Well, if you take a look, they got rid of that 90 degrees. And the 180 became 90. So what I did was I subtracted 90 degrees from each side. So this would be subtraction. Notice that the reason for 4 and the reason for 5, these two pieces right here, don't abbreviate them too much, because if you put SUB and SUB, it would be the same thing. So just be careful when you try to abbreviate and stuff like that, that I know exactly what you're talking about. Now finally, number 6, you're going to notice that A and C are complementary angles are in the proof, and down here they listed this. Do not put, and this is what students they'll do. They'll go, oh, I wrote given before, so I'm going to write prove. That is not true. You do not do that, okay? What you're going to do is you're trying to prove why this is true. So I'm going to take a look again at number 5, and what did I do to 5 to get 6? Well, if you remember, this is that kind of duh. They equal 90 degrees when I add them together. That's what a complementary angle is. So this is going to be definition of, and it's going to be complementary angles. So again, you start off your proof with givens, and then when you get to the bottom, you never put prove. You always lead to like, why is this true? Let's go ahead and let's look at another proof. Again, I start off with my given. It says that angle V and angle W are congruent and supplementary. So let's take a look at the proof. I look at number 1 and it says angle W is congruent to angle V. Well, we know that. That was in the given. So I'm going to write given. Then on number 2, it says that angle W and angle V are supplementary. Notice that's also in the given. And again, 99.999% of the time, they're going to start off with the given. Now, you're also going to notice that the proof part right here, angle W and angle V are right angles. Notice that that is down here. And again, I'm not going to write prove. I'm not going to do that. So now what I need to do is I need to look at what I have given and how do I come up with number 7. So let's go ahead and let's take a look at these. Number 3 says the measure of angle W plus the measure of angle V are 180 degrees. So I am going from 2 to 3. And that's going to be definition of supplementary angles because I know that I have supplementary angles. So definition of supplementary angles. Okay, now what I'm going to do is I'm going to go from 3 to 4. The measure of angle W plus the measure of angle W equals 180 degrees. You're going to notice that I took out the measure of angle V and I put in the measure of angle W. And I can do that because of number 1. I know that they're congruent. Because they're congruent, I can take one out and I can put in the next. Okay, so I'm going to go ahead then and I'm going to write substitution. All right, now what I'm going to do, and this is going to be a little bit of a stretch, what do I do to 4 to get 5? Now you're going to notice that I only have one measure of angle W, and this 80 turned to 90. So what they did on this is they took these two, there's 2 of these, so 2 of the measure of angle W would equal 180 degrees, and they divided 180 by 2 to get 90. So this will be division. Now I'm going from 5 to 6. The measure of angle W is equal to 90. 2, the measure of angle V is equal to 90. You're going to notice what changed here is this right here. And I know that they're congruent from number 1. So this again would be substitution. And then finally, from 6 to 7, angle W and angle V are right angles. Well, if I know they're 90 degrees, I know they're right angles. So I'm going to go definition of right angles. And that's your proof. Now, all of the things that are off to the right-hand side, I'm going to make a list at the end of this video, and I would put it on a colored sheet of paper or have it off to the side that when you're doing proofs and you get kind of stuck, you can go back through and look at a couple examples and a couple of words, and that might help you as you're working through proofs. You would not use this list on a test, but it is something that you could use to help you as you're formulating your proofs. Let's go down now and recall, this is from chapter 1, segment addition. And what segment addition said is if I have a segment like this, and this is A, this is B, and this is C, I can take line segment AB, I can add line segment BC, and that's going to give me line segment AC. So again, I'm taking this little piece right here, I'm adding this little piece right here, and that is going to give me the whole piece right here. Angle addition is the same type of thing, only rather than line segments, I'm going to do angles. Now notice that my rays have arrows on them. I'm going to call this A, I'm going to call this B, I'm going to call this C, and I'm going to call this D. I got angle ABC, that's this angle right here, plus angle CBD, that is this angle here, and that's going to equal angle ABD, which means it's going to give me this whole angle right here. And that's angle sum or angle addition. So like I said before, what I would do is I would create some kind of a sheet that's going to help you with proofs. And if you remember from yesterday, there were, of course, the givens are kind of like duh, okay? We had addition or add. We had subtraction. We had multiplication. We had division. We had substitution. These were all words that we used yesterday. Another thing that we also used yesterday were words like reflexive. And you might want to put an example of that. An example would be like angle A is congruent to angle A. It's the same thing. It's reflected on either side. So I think of reflection. Symmetric. Okay, an example of that would be if line segment AB is congruent to line segment CD, then line segment CD is congruent to line segment AB. They flip-flop. And then transitive. Transitive is really like the law of syllogism. The only difference is is it's symbols, not words. That's kind of how I see it. So transitive, it says if, and this is just an example, angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. So again, if you remember, we talked about the Oreo cookie. Here's one part of the cookie, here's the other part of the cookie, here's the double stuff in between. I'm going to eat the double stuff and I'm going to put the two ends together. So I'm going to take my A and I'm going to put it here, I'm going to put my C and I'm going to put it here, and the B is tossed away. That's the transitive property. Today, to add to this sheet of ours, what I would do is I would add definition of, and you remember in the last proof there was quite a few of them, definition of complementary angles, supplementary angles, and if you want to, you could even put it out here. And if you need to, you know, put like 90 degrees or sum of 90 degrees, supplementary is 180 degrees. You can put that. Some of the other reasons today that's different, the triangle, angle sum, where if I have a triangle like A, B, C, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Okay. So that's an example of that. Another one that you could write is segment addition. And that example is in today's notes. And then also angle addition. And you might come upon more of these as you go. But this is a nice running list with some examples that could help you when you're doing proofs. Again, you wouldn't use this list on your test, but it would be something that would help you as you are doing your proofs. And then what we'll do is we'll keep adding on to it as we go. So again, I'm going to give you a colored sheet of paper in class. If you're not in class, take a colored sheet of paper or a piece of notebook paper, and I would start writing these down with a few examples, and then that'll help you with your proofs. That is it for today. If you have any questions, let me know.